today is supposed to be like it's supposed to be hands-on. So my initial plan is to get 3 volunteers from the call that we can all do this together. So the idea is that the 3 volunteers would, with myself, we'll all form a DVT cluster, and then we'll set up like a validator nodes together. So that's the plan. So what I'm going to do is I'm going to try and buy some time by just, doing like a recap of all the things we've talked about, right? And then, hopefully we get more people to join, and then we can get started, right? So yeah. Just to recap, we're talking about distributed validator technology. And the reason why this is important to us, or why we are talking about this, is mainly to address a major concern, a major security concern, decentralization concern, and risk concern, right? The idea, or the original idea of why DVT technology is important, is that the economics of Ethereum or Web3 in general is that everybody can be involved, right? Either as a builder. So take, for example, if you don't code, right, or if you're not building tools, you could also be involved in the Web3 space in some other ways, right? So which is where, we call the token holders comes in, right? So yeah, as a token holder, and like I believe that a couple of us might have some tokens in some different networks, right? As a token holder, you are contributing, like the fact that you even bought any coin, whether it's Ethereum or Bitcoin, right? It shows that you are interested in the that you are interested in the future or the success of this project, right? So, and one thing we've also talked about is there are different kind of people or different kind of ways you could contribute as a bleeder, as a staker, right? Or it could be like as a trader, like, crypto trader and all of this, right? Those are separate people, right? Or it could be as, as a node operator, right? So the one we are focusing on here is the solo staker, as a staker, right? Or node operator, right? So, because everybody is coupled together. As a staker, what defines you or what makes you a staker is basically the fact that, sorry, 1 second. It's basically the fact that you can, sorry. Yeah, it's basically the fact that you can contribute to the security of Ethereum network and at the same time get rewarded for it. So that means for you, you might not necessarily be building, but what you are doing is, what you are interested in is that I want to just be performing the roles of a validator. And we also talked about the roles of a validator, which is basically proposing and producing blocks, and then also like voting on the validity of those blocks. That is, in simple English, the basic responsibility of a validator. So for you, you've decided you want to do that. And for you to be able to take part, or for you to be a validator, and take on this responsibility, we also talked about the fact that you need 3 things. You need a staked collateral, which is 32 ETH. And we also did the math that 32 ETH currently is about more than $100,000, all right? You also need to run 3 different softwares, right? The execution client, the consensus client, and the validator client, right? So these are the things that you need to get started running validator nodes. And then we now talked about, doing this doesn't just guarantee reward, because remember, the reason why you're doing this also is not just, for the good, but because you're also going to get rewarded, right? And like we said, the reward can be very substantial, right? You can imagine, for example, now getting like approximate of like 30% of 1 ETH, like every day, or, imagine getting that, right? Every day, or maybe like every week, for example, right? In a month, you know how much ETH you have gotten. You are not buying it. The system is giving you, right? That's what happens. So you can imagine that, it's a, it's a very, prosperous means, right? Like you could actually make a lot of money from it. But however, we've not talked about the fact that in as much as it is very rewarding, right, there are certain challenges that could hinder you from doing this, right? So we talked about the fact that there are different risks that could hinder you from doing this. And then we talk about the first risk is that the first risk of your private key being stolen, right, by attackers or by, a known attacker or whatever, right? We now also talked about the fact that the network has some guidelines that you need to follow. And if you don't follow this guideline, there are repercussions, which we call slashing and penalties. So the first repercussion is you could lose your entire staked collateral, right? That means that 32 ETH, that 100 and something $1,000 is gone and gone for good, right? I mean, but we've talked about the fact that it's a large portion and then they remove it from the network, right? That's one. And then the second one are penalties, like if you miss getting the reward, right? So, we talked about all of this, right? And then we now talk about how do we solve this problem? How do we take or participate or be a validator node, a validator runner, or participate in the security of Ethereum without facing the repercussion of all this risk, or by de-risking ourselves? And that is where we talk about DVT technology and all the problems it solves, right? And then in theory, we talked about 4 major components of DVT. We talked about the Shamir shared secret, which is basically the way that it splits a validator key amongst a certain number of people. Like it splits one validator key and gives that portion to certain number of people, right? This is also the DKG process, like the distributed key the distributed key generation process. So the process by which the distributed key generation process works is by using the Shamir shared secrets algorithm or cryptographic algorithm, right? So this cryptographic algorithm just finds a way to share these keys in portions in a way that it can reconstruct those keys back without talking to each individual as I share that keys amongst, right? And the process of doing that in a secure manner is called secure MPC, or secure multi-party computation, which is what we also talked about, right? And then the final part is now where once all of this is done, you are now like the group of people that this key or this validator key is split amongst can now collectively perform the role of a validator, right? And then in return, they can now also get rewarded. So it's now left for you or the cluster to now determine how do you want to get rewarded. Do we want to split the reward? Maybe you have a model where everybody come up with the capital. We all come up with like 8 ETH each to make up 32 ETH, and then we also like split the reward. So you see some of the problems that this also solves. That means that for you to participate and be a validator node runner, you necessarily don't need 32 ETH. But if you can find a cluster of people, n number of people, let's even say it's 10, you can divide it by 32, that's 3.2. So that means that you can just even have 3.2 ETH, and you can begin to get rewarded and get started staking on Ethereum, right? Those are all the things we talked about. And now today we are going to be showing you how that is done, right? And what we are going to be showing today is basically the distributed key generation process, right? Where we are going to be forming a cluster of four validator runners, right? So the idea is that 4 of us want to be a validator on Ethereum network, and we want to do that without having. Not all of us have 32 ETH. Maybe I'm only the one. I'm the only one that have 32 ETH, right? So I'll show you all of that, right? And then you'll see that everybody will be able to create do a DKG ceremony. I think the most important part is the DKG ceremony, right? The second part is how to run a validator node, right? Which we also already discussed yesterday. All the nitty-gritties of running validator nodes, all the basic concepts that we need to know, right? So the idea now is that at the end of this session, you will perform the DKG process together, and we'll run a validator node. And technically, once we are doing that, after like the next epoch will become activated as a validator node or as a validator on Ethereum testnets, right? And then we can now start talking about how to now go mainnet to do this, right? All of this is just demo. We already have our testnet ready. We'll talk about which we'll talk about at the end of the day. But yeah, that's it. So first question that I want to put to the house is, how many people would like, I would love like 3 volunteers. Like I need 3 volunteers, right, to participate in this workshop with me. 2 things I need from you is, I hope that you have like a laptop with you where you can run like a validator node. Don't worry, we already simplified all of those things in a simple Docker compose or in a simple command that I just run and everything will be fine. So you don't need anything technical here, right? You need that, and then you need a MetaMask wallet. So if there is awesome. So if you have a MetaMask wallet, I just need to give me like your ETH address, your ETH address. Just give me that, and we'll get started. So I need 3 people that we can do this together. So these are the people that will be forming like a cluster together, and then we can get started. Oh yes. All right, Osaru, yes. So while we are waiting on Okoyemi, okay. All right. Any other? You can create. Remember, in our previous classes, we can create different number. We can create more than any number, right? There is a algorithm that determines the threshold signature. Basically, the threshold signature is how many validators do I need? Even if I have 100 validators in the cluster, how many of them do I need to sign or to perform a validator node function, right? So it doesn't matter. Thank you. So yeah, so for the people that showed interest, Ifeoluwa, Osaro, Okoyemi, please do share with me your ETH wallet address, right? Oh, sorry, I thought Ifeoluwa was volunteering. I saw. Oh, sorry. So we need one more. Volunteer. If let's say I can give a wallet address, but I want you to be able to sign. Thank you, Emmanuel. So yeah, so we have Emmanuel. So we have 3. So we are already complete. Problem 1 solved, right? So the next thing I want to talk about before we get started is that, we've talked about DVT technology, right? However, one thing I want us to know is that there are two companies that are actively bleeding that solution right now, or it's not even actively bleeding. They've built it as a client, as a software, right? That people cannot bleed on, like people like BlockOps cannot bleed on, right? So I'm going to quickly talk about 2 of the 2 clients, which is Obol Network. Obol Network. Let me check the URL. Obol Network and SSV. Let me drop that for us as well. Let me share this tab. Obol Network and SSV. So these 2 are the major players in the field, right? These are the major, and I think as of my last knowledge, most of them are just getting started, to be on mainnet, right? Some of them have been on mainnet, but everybody's still experimental, right? Everybody's still, trying to perfect the software, right? So like I said, it's a pretty new technology, right? So this is SSV, right? So I just want to explain sort of like the nuances between Obol technology and SSV, right? So Obol, like I said, they have like a DVT client that they call Caron, right? So Caron is sort of like you see all of those things I've talked about, like the architecture of a DVT technology, of DVT, the DKG generation, the reward splitting, all of those things have been compacted together into a permissionless software by Obol, right? So Obol and SSV. SSV, by the way, is the first in the field. SSV is this. In fact, the idea, the whole thing started from SSV, right? Because I remember that SSV, the full meaning of SSV is secured shared. I can check, right? But like the full meaning of SSV is literally DVT, right? Is literally like it was coined from like the old DVT paper, right? So SSV is one of the first player in the field, and then there's Obol as well, right? These two people are they have really great software, and a lot of networks or a lot of node operators are now using them, right? And what we are going to be doing today is, but because SSV is permissioned, we won't be using SSV, right? Because when I say permission, it means that you need, you can't run that by yourself. You need like approval before you can get started on it. But on Obol, you can actually get started, like it's permissionless. So we can do all of those things by ourselves, right? And that's what I'm going to be showing us today. So yeah, let's get started. So yeah, it's a good thing that we already have 3 volunteers. I also have my own 32 ETH that we're going to be using. Let me go to where I need. Sorry, let me stop sharing and share another screen. All right. So yes, so let's get started. So you can see this is my MetaMask wallet. You can see that I already have 32 ETH. I want to make sure that I'm seeing everybody. Sorry, 1 second. All right. Yeah. So this is my MetaMask wallet. You can see that I have the first thing that I need, right? Remember 3 requirements to be a validator of 32 ETH. I have 32 ETH, right? So what I want to do is for everybody that share their wallet addresses with me, to make this simple, I'm going to send 8 ETH to you guys so that we assume that all of you have collateral, right? So basically, we are assuming a situation where we all come together to contribute 8 ETH each, right? So that's what I'm going to be doing. Or otherwise, I could also be the only one providing the capital. But because I want us to actually be involved, please, for everybody, please, I want to trust that you will send my ETH back. This thing is hard to get. So I'll send you 8 ETH. One I've sent to Opayemi. Then I'm sending to Osaro 8. I'm sending to Emmanuel. So guys, just confirm once you receive it, right? And then, before we even get there, you'll have gotten it. All right, so you can see that I have less than how many ETH left, but now let's get started. So for Obol, there's a launch part. So what I need to do first of all is so what we want to do today is the DKG process, the process of splitting a validator key amongst 4 of us, myself, Emmanuel, Osaro, and Opayemi. So that's what I want to do today, or with the DKG process. So what I want to do now is connect my wallet, right? So you see my wallet is already connected, right? Yeah, so my wallet is already connected, so you can see that. So If you are also there, you can also start it on your hand and connect your wallet, but don't do anything yet. Just follow me as we go, and I would explain things, right? Yeah, awesome. So now that I've connected my wallet, so what the Launchpad is going to ask me is that what do I want to do, right? And do I want to create like a validator cluster, a data validator cluster as a group, or I want to create it alone, right? But because what we want to do today is to create a validator cluster, I select that, get started, right? And then, just like we saw last week when we were trying to create a normal validator node on OSKI, right? We saw the normal process, right? This is also somewhat similar, right? So you will see, it just give us like, all the basic things that we need to know, right? It's letting us know that, okay, we're about to create a distributed validator cluster, and it is very important that we keep all of the keys that's going to be generated here safe, right? So I can get started. You can read all of these things on your own too, which is why I shared the link. I think that for everybody that was here last week, we've gone through this process together. You are here to receive your ETH. You should have received it. It's confirmed here. Oh, so if you need to check your network and make sure that you're on OSKI. If you're not on OSKI, Emmanuel, are you on OSKI? Emmanuel?
Yes, I am.
Because you should have received it. It's already confirmed here, so you should have received it. You can see that all of this has been confirmed. Oh, wait, actually, did it send? I don't think it sent. 1 second, let me, because I can see that my balance is more than. 1 second, let me just do that again. All right. I just realized that the last activity was 0. So it's possible that I didn't send anything. Yeah. So you should receive it soon. You should receive it now. All right. So yeah, just signal when you receive it. All right. So, all of this process from last week, you're already familiar with it. I said, just read everything on your own terms, right? You also, this is just them like, making sure that they are not liable for you losing your keys, just pretty standard of all softwares, right? Just also letting you know that there's risk involved, like awesome, Manuel. Just also letting you know that there's risk involved, right, in working with a group. So you need to make sure that the group of people that you choose to work with are trustworthy people, right? We don't want to work with a group of people that will connive on you, right? So, at the end of the day, there's still a level of trust that still, it's trustless at the end of the day, because a lot of these things still is not possible with DKG, with DVT. So this year is just confirming that, okay, you've understood everything that needs to be done, and yeah, we get started to configure our DVT cluster, right? Now, the first thing is going to ask us is, what's our cluster size, right? So let's give our cluster a name. Let's call our cluster Leaders Connect Lagos. Let's add our own tag to it. Block Ops Leaders Connect Lagos. So this is what our tag, our node is going to be known for, or known as on chain, right? So it's not asking us what's our cluster size. So our cluster size could be anything. It could be any number of people that is going to be joining the cluster. But remember, for us, it's 4. And you can see what I was talking about around this threshold signature, right? So you see that if it's 10, you see this threshold that it says 7/10. Basically, for what I've explained in our previous classes, what this means is that it needs 7 of these validator, of these people that form a cluster at any point in time to be available to sign and perform the role of a validator, right? And I think I told us also how this threshold signature algorithm works, right? So basically, you just do that. But for now, since we are 4, let's just reduce our cluster size to 4. And then you see that what it's telling me is that my threshold size for this cluster of 4 is 3. That means that at every point in time, 3 people need to be available to perform the role of a validator. So that means that it's okay for someone to go down, but it's not okay for two people to go down at the same time, right? There will be penalties. Do you understand? So yeah, they will now get all the addresses for this one. Because I'm the one creating the cluster, I'll still use my address for the first operator. Then what I'm going to now do is get everybody's, add everybody's ETH address. So I'm adding the one for Kwemi, I'm adding the one for Osaro, and I'm adding the one for Emmanuel. So you can see that everybody has ETH, so we are covered. So what I'm now doing is I've added everybody. So this is all of us that is going to be, doing the whole work. Then it's not asking me that how many validator nodes am I running? You can already see that the collateral is already there. So for every validator node or for every validator, there's 32 ETH requirements. So if we want to run 2, that's 64, but we can't afford that. So we can only afford 32 ETH, right? So then we go there. Now, one thing we now need to do is to generate an ENR. ENR is basically Ethereum node, is Ethereum node, I'm not good with all these acronyms, Ethereum node registry. So the idea is sort of like your node identifier, right? It's a way for, it's how you are seen, on chain or, amongst all your peers of validators, right? So one thing we need to do is to generate our ENR. And for you to generate our ENR, what I'm going to do is, I want everybody, for all of us that is participating in this, to clone this repo, because you are going to need it regardless. Clone this repo, right? So I'm also going to be doing that. Let me show us. I'm also going to be doing that on my end, so we can follow along. Let me actually see if I can divide my screen. 1 second, let me get rid of these personal stuffs. Let me reduce, because I want everything to be on the page so we can all see all the action that is going on. And second, sorry. All right, so this is my own terminal. I'm also going to be cloning some of these. So I hope that some of us have already started. So I'm cloning this. Right, so you can see it. Right, and then I'm running this command as well. So I hope that, so let me just do like a check, like, is everybody doing that for the 3 people in the cluster? Are we all doing that? Sorry, I can't see. Yeah, are we all doing that? Can we signify? Okay, okay, Osaro is there. Who else is there? Emmanuel, probably check your internet. It's a, all right, so just clone and just follow this instruction. So all I just need you to do is follow, let me just share it with us. Just follow these instructions. Let's also be fast because of time. We still have a long way to go. Just run these 3 commands, basically. Right? So I'm doing that on my own end now. Don't worry about the integrity of the command. So once I just do that, what I'm going to do is I'm going to run this Docker. What this Docker command is going to do is generate an ENR for me. So this ENR is going to be my unique node identity. So watch me as I generate my own ENR, right? So you can see it has already generated my ENR private key for me. Of course, this is not an information that everybody should be seeing, but because this is for demo processing, demo reasons, right? So it's fine. So he has already generated that ENR and saved it on this part on our machine. So if you have done this, let me know. But I'm going to copy this. So what I'm going to do now is copy my ENR, and you guys are going to need it. So it's very important that you copy your ENR and save it somewhere, because you are going to need it soon. So what I'm going to do now is copy my own ENR and paste it here, right? So I'm good. How many of us have done that? All right, so as I'm waiting, so you guys can just, so that we don't waste time, you can just, follow me along as you are doing it, just signify so I can also continue, right? So what we are now, once I've added my ENR, once part of the configuration I now need to do is to determine how I want, remember, the reward, how I want, or how our cluster wants to be rewarded, right? First of all, this one is the default. The default is basically assuming that I'm the one providing the collateral, and at the same time, I'm the only person getting all the reward, right? But in this case, we want to split our reward amongst everybody, right? So that means that we are all coming together to contribute 8-8, right? So it is very important that we also split the reward amongst ourselves. So again, I'm going to be copying adding Okoyemi's Ethereum wallet address here, because that is where he's going to be receive his wallets in. His reward. And then for Osaro, and then for Emmanuel, right? You can see I have like a cluster of 4. I can remove all these ones. So you can already say that the split is, he's already calculated the split for us, right? Oh yes, remember, oh sorry, I made a mistake. We are splitting principal and reward. Principal meaning like the collateral amount. So that means that it's important that I need to add everybody here, not the first one. So let me do that again. Poyeme, Osaro, and Emmanuel. I hope we've all generated our ENR. So let me tell you the command. Just run this command, Emmanuel. Just run this. It will work. This is the command, the exact command you should run. And you should have Git on your laptop for it to work. Just run this and let me know what it says. All right, so I'm going to just limit that to just 4, so you can see. So it's already calculating how much ETH we all need to contribute. So which is like 8 ETH, 8, right? So that's the calculation. And then what else is complaining about something here? Because usually we're supposed to proceed, but I can imagine that maybe sometimes some of these things can be buggy. So let me see. Let me start again. Anyways, let me just save time and use my address. I think their site is buggy. Oh, sorry. Lookups leaders connect.
You're on mute. We can't hear you.
Oh yeah, sorry. Sorry about that. That's a Mac problem. I went to swipe left. So yes, get it. Please, can we paste the wallet addresses again for the 3 of us? We are running out of time here, so I can do this DK process. All right, Emmanuel. Let me hide Emmanuel as operator here, myself. Emmanuel, are you able to clone the repo and do that? Osaro and Okwemi. Okwemi, your address. So once you have all of that, okay, let me copy my ENR again. I hope that we've also been able to generate our ENR.
Yeah, I've been able to generate the ENR key.
Okay, awesome, nice. Just keep it safe. We are going to need it soon. Then I had on my operator. Now that I've done everything, I don't understand why. Okay, so everything checks. So now I cannot move ahead and create cluster configuration, right? So what is my problem? I went back again. Okay, yeah. So now it's going to confirm. I want to confirm all of my configuration. So it's asking me to confirm this is our name, just like a summary. These are all the wallet addresses. We want to create one validator. This is my ENR. This is where the principal is coming from, and this will not work. You guys might need to send me it back because I don't know, for some reason their platform is not allowing me split principal, but maybe it's just a bug, right? So you guys, as you're talking, please try to send me that ETH so that, because now I've already said that I have all the ETH, so it's going to expect me to be the one to do that. So you can just send the 8 ETH here, but you guys can just keep doing that while I keep explaining the rest. So I confirm the details, and then what I'm going to need to do is confirm and sign. So of course, I use my Meta Wallet to sign, and then once I sign, I move on. 1 second. Oh yeah, so it's not proceeding. It's not proceeding simply because I don't have 32 ETH, right? And probably I should try it again. Okay, don't worry. But I think we already get the gist of the matter where all of us can see split. Maybe we can raise a bug with the Obol team and let them know that the splitter for the principal is not working. But while we are waiting, let's confirm how much we have now. I think, okay, someone has sent already. We still need another. We still need another. We're almost there. We're almost done. It's a very simple process, but I believe that as we are doing it now, we will all be seeing, like everything will be making sense to us.
I think Okoyemi has his hands raised. Maybe he has a question.
Oh, Okoyemi, please go ahead, please. If you have something to say, you can just unmute your mic.
Oh yeah, sorry. I wanted to suggest that maybe it didn't work because you didn't have up to 8 ETH in your accounts at the time.
No.
You understand?
Yes, that's true. Oh yeah, now should we try it again? But I think the reason why, yeah, I wanted to say, because I want to avoid, but I mean, since it's pretty much fast for us to send, let me try and send it back to Emmanuel and see if that will be fast. But otherwise, let's just quickly send it back so we can move on because of time. Actually, I'm trying to avoid this thing being a blocker. So let's just, what's the best way forward here? Let's just send it. Let me just be the principal provider for now, right? We can always do this again. But the idea, because I don't want us to waste time, we're already like 15 minutes gone. So if everybody can just send the ETH now. Yeah, it's not going to work. Asaro, what's up? Opeyemi. What's the update? What's the update? Time. All right. Opeyemi has sent. Okay, I have 32 now, so that's good. So if I sign now, it should work. Right. I don't understand this guy. So let me do that again. Confirm and sign. So this is a problem on the end. You can see that bad requests. Did you even not fill everything? We filled everything. So yeah, this is the thing about demos. Shit will always go wrong. This is strange. But anyways, the good thing about this is that I have a backup, but the only problem is that so there is another cluster invite. So at the end of the day, what happens here is, let me show us 1 second. Let me just open this somewhere else. Because the idea is just for us to understand these things, right? It's not necessarily like it's a demo. It's not necessarily like we are going to. So what I'm going to do now is I'm going to connect to another wallet. It's just the stress of transferring it up and down. So this wallet already I've completed the DKG process, right? The one I have here. So if I go to the launch pad, you should see my, let me see, I think they have like dashboards. Yeah. So you can already see I've already created one, right? So this is it here. So what it does is exactly, so this is it. So cluster of 4, right? These are the wallet addresses, just like us that did that. These are all the 4 wallet addresses. And then what it will now do for me is that it will now generate a cluster invitation URL. So I'm going to share the cluster invitation URL for this to us. So that we can also take a look at the signing process. So for the 3 of us, let's go through that. I'll send that now. 1 second. I saved this here. So this is a cluster invitation link. So if you click on it, right, what is going to happen is that for every operator, 2 things that you're going to need. 1, you are going to need to put your ENR. So you see the, sorry? So you see the ENR that you generated earlier, right? So you are going to need it, right? So the 3 of us can share that link and see. Let's see what that says. I really wish this one worked. Yeah, there's not too much you can do if their site is, yeah, they are, yeah. So create, let's see whether it works now. Confirm and sign.
Nice.
Awesome, it worked. So is the API that's been misbehaving. But anyways, wait, can we see my screen? Can I see my screen?
Yes, we can.
All right, so we are done with our DKG process. So what we are now going to do is, so for operators, I'm going to send you an updated cluster invite, man. So I'm going to send us an updated cluster invite, but I want one of us to share, so any one of us that is willing to share his screen and show us how he's also accepting to join the cluster so that we can also see. On my hand, I've created the cluster configuration, right? You can see it here. And you can see this page here. I think we should even screenshot this page for the grants, right? That's, you know, our cluster, we've been able to create like a DVT cluster for, you know, Breeders Connect, right? And this is the link to invite the operators to join, right? Let me shut that. So who wants to volunteer to show us? So what I'm not going to do is I'm not going to wait for everybody, the three operators to join this cluster. So for them to join the cluster, they will now need to sign with their ENR. They will need to sign with their ENR and their wallets, and then I will see them. So you can already see here that these are the wallet addresses for Emmanuel, Osaru, and Okpemi. So you can already see he's waiting for them. He's waiting for them. I mean, as the cluster already signed, so let's wait for the three of them. So who wants to volunteer to like share the screen as they are doing this, while the other people to continue doing theirs, and then we can see. My screen is messy. It's messy. Wants to volunteer? Nobody wants to volunteer. You have to volunteer, or I'm sorry. People need to also see your screen and see how this is done, so that you know. I mean, like I did Mago anywhere. I already feel of this. Okay, awesome. So, do you want to let's share it so you can share your screen? I'll stop sharing so you can share your screen and show us. Because, like I said, Okwemi will now also sign, you know, and then join to be the validator. And then on my hand, you also start seeing if any of you also want to monitor it, you can also see it. And on my end, we start seeing the number of operators that have joined and the ones that are left.
Can you see my screen?
Yes.
Okay.
You can see exactly. So you can see you already showed in the invite that you've been invited to join this cluster as a validator, right? So you walk you through a couple of processes that you need to go through. So Kwame is going through them, right? All right. So you say get started. You know, all the basic stuff I also did, right? All right. So exactly. So you paste your in here. By the way, I hope Osaro and Emmanuel, I hope you guys are doing yours too, so that we can quickly wrap this up. Wait, Osaro is on the call. Hey, our last operator is on the call. Yeah, it might take a little while, but it's be done soon. Awesome. Is it done? Yes, it's done. So so let me share my own screen now. So if I share my screen, you would see that you will see it to confirm that let's see it. So you can see that I can confirm that this wallet address, which is Opeyemi, has accepted. So we are now waiting for Emmanuel and Osaru. I don't know who is which, but we are waiting for them. Since Emmanuel is on the call, Emmanuel, how far have you been able to do that with us? Oh, okay. Oh, are you having issues, Emmanuel? All right. So, but the good thing about this is we can always continue this later on, like, but this is the DKG process. So now what we now need to do is that for everybody currently that cloned that repo, just type this command. Type this command, and let's assume that we still need 2 people to sign, but let's assume that everybody have signed because of our time, and let's assume that we are ready. We have our keys, right? We are ready. So what we are now going to do is run this command. What this command is going to do is it's going to set up a validator node for you, right? With all the things that you need. So on my hand, I'm setting up that command now. So I'm running that command now. So I'm running Docker compose up, right? So you can see that. So the things that you to do is, okay, let me first of all clear. This one is my own laptop issues. So I'm going to run the command again now. It shouldn't give me an issue. Right. So if you run the command, everything should start spinning up like this, right? So what this is doing is, like I said last week, is setting up an execution client, a consensus client. I'm using Nethermind, right? And so what it's now going to do is going to start syncing my execution client and my consensus client. And remember what I told us last week, that you don't want to add your keys yet until your execution client and consensus client is synced. So what I'm going to show us now is I'm just going to sort of like try and see if we can see like a dashboard for it, right? So usually part of the things that comes bootstrapped with this is the observability for it. And which is part of the problems that BlockOps already solves, right? So if I go to 3000, I can see like the dashboard for my current, for my node. So this is where I will now see like the activities. But because nothing is really happening yet, the node is still syncing, right? So there's nothing much to see. But this is where you now monitor like the process or the progress of your validator. This is where you can see it's saying no data, no data, no data. So no data is basically saying that, yeah, this thing is running, but like it's not receiving data yet. So, but until the service is done, that's when we start receiving data. So you can see that it's syncing, right? So it's just basically going to start performing all the processes it needs to sync. So yes, that's everything about the DKG process. And what we are going to do now is that, and that's basically how everything works. And one thing I want to now show us is how we can now do this live, right? Like I said, remember I said that we've already solved this on BlockOps end. So what we now want to do is BlockOps, we already have, so I'm sending this link to us. We already have this solved. So what we are now doing now is we are creating clusters of validator node runners, and people will now be showing interest in joining. So that means that you can now decide to come and stake, or come and be a solo staker with maybe like it's 2 ETH that you have or it's 3 ETH that you have, right? So to do that, all you just need to do is just show interest, just put your email address here, and then we are going to reach out to you, right? Yeah, so this is sort of like where we go from here. Moving forward, what we are going to be doing, part of the things as block ups that we are doing is we are doing solo staking, and we are providing infrastructure for solo staking and institutional staking. So basically, for companies that also want to, stake their funds, like maybe like companies like Onboard or Quidax or whatever, right? They can now also like come and they can create like a DVT cluster in a secure way, right? And even for us here on this call, if you want to join, you can also join, right? So please feel free to fill out just put your email address and, show interest for our early access. We currently have our testnet running, and what we are just going to do is add you to our testnet. And if the testnet is successful, we have like a period of 2 weeks, right? If the testnet is successful, then we'll now go on mainnet. And this is where we'll now do this is where your actual money and actual reward now start coming in. And if there's anything about the Web3 space that is the point of, you have to first of all test your products in testnet first before you do it in mainnet, because you don't want stories, because your funds, everything happens once you get to mainnet, what happens, right? So yes, that's the end of our series. That's the end of our talk. I hope that it has been helpful. Obviously today that we will have that we did the showcasing, we didn't see a lot of people, right? But hopefully the recording is going to help, and everybody can watch this and get the gist of the matter. So yes, that's it. Any question so far from anyone?
Okay. Thank you very much, Adedayo. And big shout out to you and the Block Ops team. I have a question. I think you tried to answer that in the last session. And it's like strategies for maximizing the returns. Aside the MEV booster that you spoke about, are there any other things that you can use to take advantage of? Yeah. Maybe I say cluster. Yes. Like we can earn more than maybe other people out there.
So another strategy is to make sure that you are using a very beefy machine. So things, right? But everything is software, right? So you need to make sure that you have a machine that can process or compute fast. So that's why there is like a requirement. Maybe it's 4 cores. It is very good for you to make sure that you are not using anything lower than that, so that you are optimized. That's one. Second, you have to make sure your bandwidth is fast, right? Like your internet bandwidth, right? Because see, the problem that we had during that demo is because the API was not working fast, right? So you want to make sure that your bandwidth is fast. And if you're able to do that, that means that once you are given the responsibility of validating the transaction, you're able to do it fast. And you're able to do it fast, and you're even able to do it at all, you get rewarded. The problem is that part of the reason why most people don't get rewarded is because they are not able to do it fast, and then they miss the opportunity, they miss that window, or their computer is even too slow to be able to process that. Do you get? So in addition to that, you now have the MEV boost, right? And be doing maintenance, all the things you just have to do is just be billing and balling, right? You don't need to do any other thing again, right? So yeah, does that answer your question?
Yes, absolutely it does. That means that there's really no hope for the average PC user. And it
really,
goes to show
not really.
Yeah.
Not really. It depends, right? Because the problem with PC is that you can close your laptop and then your node goes offline. But the good thing is that now with DVT, because you are running a group of people, and remember we said that one node is allowed to go down. That means you can just tell your guys that, okay, guys, I want to restart my laptop. Just make sure that the 3 of you are online, and I can easily do that without any problem. Do you understand? So that means that,
Yeah.
I mean, we can just communicate. I can just communicate within my clusters and let them know that, okay, if I want to use laptop, I'm trying to let you know that it's still possible for you to use your laptop, right?
Yeah.
As long as you people manage that threshold signature to make sure that at every point in time, the number of threshold that is required is online. So you can just tell your guys that, oh, me, I want to restart my laptop, or, we're having power issues. So do you understand? Like, everybody else can be doing the work. So yeah.
Yeah. Thank you very much. Thank you.
Awesome. Thank you. Thank you, everybody. This is the end of the session. Okay.
Yeah.
Oh yes, sorry, I just wanted to contribute to what he asked. So I mean, a way of earning more rewards. So I was looking at this new, let's say, technology. It's called Eigenlayer, right? So what it allows you to do is, as a validator, you can run software for other blockchains, so to say, right? So I mean, that's still kind of new, but in the future, I'm sure it's something that we could also be looking at.
Yes, exactly. Appointment. Thanks. So yeah, that's also another way for you, because another thing that Eigenlayer does that Appointment is also talking about is the restaking. So like, even your staked collateral, you can also be making money off it. So what happened is that, I think we also talked about it in our previous session. We talked about it, I think it's our first session that we talked about it, where someone was asking the question. So you can now even restake. So instead of your stake collateral, your stake it just sitting there, you can now, so what Eigenlayer will now do is, Eigenlayer will give you some form of token or something, right? Where, you can probably spend, or, you can now even like restake it somewhere else. So instead of that token on it just sitting there, you can still use that locked collateral to do other things. Maybe it's liquid staking, or you can even, in fact, there are some platforms now that give collateralized loans. So imagine that you have 32 ETH now. It's $100,000. You locked it somewhere, but you need cash, right? And you've already locked it. You're already getting reward. As long as that cash is, there are already some protocols now that are now doing loans, those secure loans, where as long as there is a way they do it. So what they just do is, you have 32 ETH stake somewhere, lock somewhere. Okay, you know what? Because of that, you want a loan of maybe $10,000 or $20,000, right? So they can give you that $20,000 loan, and you realize that because of that, you don't get to be stranded, right? And then you can still make use of your cash. I will have to look for other people that are doing this, but I know there are some people building some stuff like this. So yes, that's it. Thanks, Opeyemi.